Hey everybody, and welcome to another JASP video. In this JASP video, I'm going to be talking about a new module that came out with the newest version as of January 2024. Today, we are going to be talking about the new process module. Now, if you're not familiar with the name process, then you haven't seen it in action in SPSS, which was like the gold standard, right, of statistical software, especially for social scientists, including myself. Process was a creation in, I think, the early 2000s, if I'm not mistaken, somewhere in that range, as an add-on for SPSS, so you could do mediation and moderation. So SPS Base did not have the ability to do mediation and moderation. You had to do some funky stuff, and it really didn't work. And so Process was created to bridge that gap, so people would still use it. It would work. It would basically work in a in like half syntax mode, half GUI mode, but it would spit out a ton of information that you would need to do mediation and moderation. And it could do simple mediation, simple moderation, but it could also do complex mediation and moderation, and it could do mediation and moderation in the same model. It is pretty awesome. And so it ran into some problems, at least as far as I'm aware, in the last decade or so, as being not as robust with new methods as it could be. And so people were looking for additional ways to do it. Of course, the mass migration to R, and then, of course, the creation of JASP and Jamovi sort of helped move people along to these free programs that are in the same vein as SPSS, but not quite. So that's the brief history of Process. I've missed a ton of details. If you want to add some more context, please do so in the comments down below. I'm sure lots of people would love to know more context about Process, but that's why this module has that name, because it has roots in previous practice, right? So as you know, if you're an avid JASP user, you've got all of your modules on the top bar, and they are in alphabetical order. Now, you got to get yourself 0.18.2, whether it's the Intel version or the Mac Silicon version or the Windows version, of course, for all of you folks out there, of course, the other platforms that you can get JASP on. So you got to get that one that came out at the beginning of the year. They dropped it on January 2nd. It was great. They had their days off for the holidays, and then boom, next one drops. So to add your modules, of course, again, alphabetical order is this list. They all come in JASP. So JASP is getting slightly larger as more modules are added. I think this one's about 2 gigs or something like that. Once it's fully installed, somewhere around there, it's getting close. It's 1.6 maybe gigs. So it's getting big, but all of these exist in the app. You just have to activate them by just checking their box. So as I overdo it in all of my videos, as you can see, I have all of these checked even if I don't use them. So we are going to add the process module here. We checked it. It is currently in beta. So just be aware that there are still kinks and bugs that they're working on. Of course, they're going to need feedback. So if you are one of those folks who like giving feedback directly to the devs, please do so at jasp-stats.org. Somewhere on here, right? I guess you could, no, they actually don't have their website on their splash page. That's kind of funny. So just be aware of that. And they've got, and go ahead and support them if you can. To use our process model, you can see that it is grayed out. That means I have to have data open. But as you can see, the process module here is exactly what you would see as a simple mediation model. So its icon really helps you out if you need to use the process module for mediation or moderation. So let's open up some data. Now, I am going to open up some data from the data library in regression. I'm going to kind of make up the ways to go about it. I'm going to make it up. I'm going to open up the full wrapper for it, which has all of the output and everything. So that's this one. If you just wanted the data, you would open this one, right? So this opens the whole JASP file. Okay. And I am going to grab exam anxiety. I was playing with this one yesterday as I was preparing to make this video. And it's not necessarily a good mediation or moderation. It's not specifically made for MedMod, but it'll do it. We have several variables that we can play with, and opening up the full JASP will tell us what each of these are, and then we'll go through the MedMod, because obviously the correlation is what is Pearson's correlation is what. That's weird. It said regression, but whatever. But anyways, this is from Andy Field's Discovering Statistics Using SPSS Statistics, right? So this is a fictional data set, and we've got several variables. So let's go ahead and open up the variables here. We've got code, we've got revise, we've got exam, anxiety, and gender. Let's go back to the output here, because this is going to go away once we open up process, and you can see it's available to click on. So we'll get there in just a second. So code was the participant's identification number. We're going to ignore that one. Revise is the time spent studying for the exam, and it is in hours. Their exam performance in percentages, so that it's a whole number percentages. Their anxiety score on the exam anxiety questionnaire, which again, fake. And then their gender. We're going to use revise, exam, and anxiety. I'm going to create a mediation model to talk about how this works. So what we're going to do is we're going to open up process. We're going to click on that, and it's going to open up process here. And in the beginning, you get the model summary, and it gives you the Hayes model number, which we'll talk about here in just a second, the AIC, the BIC, the log likelihood, the N, and your degrees of freedom. And here it says, note, at least one model is incomplete or no model is specified. Please add at least one model and complete specified models. So you kind of have to do this in a linear fashion, but I'm going to go ahead and open up the JASP help. I'm going to put it over here so we can look at this together, because this JASP help file is phenomenal. I know we've gone through several JASP modules, like, learn stats, where the help file isn't actually active. There's nothing in it. This one is solid. And it's because it comes from several years of explanation, right? So conditional process analysis, hence the name process, right? So this is mediation and moderation. So in the general linear model, and specifically in multiple regression, sometimes variables have indirect effects on other variables or other processes of variables from X to Y. And then sometimes you get an interaction effect between predictors, right? So conditional process analysis allows users to test moderation and mediation effects as well as combinations of both effects. This makes it really strong, especially if you've got a significant model that you need to run. In moderation effects, the relationship between X and Y differs depending on the value of a third variable, W. W is going to be used in the options here. So W is always given as the moderator. I'll show you that. A mediation effect is a causal chain where the effect of X on Y goes either fully or partially through a third variable, M. Again, M is going to be used in the actual options here, so we'll go through that. That's the mediator. Conditional process models combine multiple moderation and mediation effects. For this video, to not make it long, because this is a massive module, I am only going to do a simple mediation effect. I'm only going to do a simple mediation effect. So that'll be this one here. Okay. And that's what we're going to do with our exam anxiety data set. Okay. And so these are various ways that mediation works. Now, the interesting thing is that this is a causal assumption, right? So it doesn't say that for moderation. You can also do moderation with ANOVA, right? With factorial ANOVA, so you don't have to do this. Now, conditional process models in JASP are conceptualized on structural equation modeling. So it makes two assumptions. Exogeneity, the parameters of the conditional distribution of dependent endogenous variables, so that is the thing that we are attempting to predict, given independent or exogenous variables, so that is what these are variables that we're predicting, should be unrelated to the parameters of the unconditional distribution of the independent variables. This implies that all omitted cases of the dependent variables are unrelated to the independent variables, or pseudo-isolation. So essentially what we're saying is that, so to put it into simpler terms, imagine you're conducting a study where you're interested in how one factor, we'll call it A, which is the independent variable, influences another factor, right? So variable A should not be influenced by any outside factors that also affect B. In other words, there should be a clean separation. A affects B, and there's nothing outside of A that's influencing B, but also related to A, right? So that's what exogeneity means. Local independence, the absence of covariance between or residual variances of two dependent variables, implies that given the other variables in the model, the two variables should be independent. This implies that they have no omitted common causes. So in other words, so I'm a movie guy, so let me give you an example of this. It's like saying that if you have two characters in a movie representing our dependent variables whose stories seem unrelated, so they have no shared scenes, let's say, no covariance, then they should be indeed independent of each other once you consider all other elements of the movie, right? So other variables in the model. There are no hidden plot lines. There are no off-screen events. These are the omitted common causes that might link these two stories together, these two characters' stories together. So that's what we're talking about here. We also need to make the assumptions about the data itself, right? So the estimation is maximum likelihood, which is the most common SEM estimation method. I don't believe you can change that, but we'll look. I didn't notice that yesterday. Conditional process and models in JASP require all dependent, those endogenous variables, in the model to follow a multivariate normal distribution. This implies that all univariate distributions of dependent variables should be normal. So we're expecting normal distributions all across the board. All bivariate associations between dependent variables are linear, and the distribution of residuals does not depend on the independent variables. In other words, they are homoscedastic with a C. And so they are homoscedastic, okay? So the residuals don't depend on the independent variables. We want the independent variables and residuals to be independent of each other. So then, of course, we go through and input stuff. So let's go ahead and do that. Sorry, this is going to be a bit long video, which is why we're not going through the whole thing. You can explore as much as you want on your own, and I'd be happy to answer any questions. So our dependent variable, I think, makes sense to be the exam. Okay, so what was their exam score? And here you put in all of your continuous predictors, so scale or ordinal variables. And here's where you put in all of your categorical predictors. You have your two nominal kinds of variables, text or not, or ordinal variables if it's categorical. I'm not a fan of the overlap here, but it's not mine. We're just going to do a mediation. So I'm just going to grab revise and anxiety to be our continuous predictors. Okay, so we have that in. We're going to skip categorical predictors here, but if you wanted to do a moderation with gender, you would put that into a categorical predictor. Now up here, we still have no completed model. And then in model 1, we have no information. I like how you can like collapse this if you want to, right? In case you're running multiple models. Okay. So I'm going to just open that up. So now we need to specify the model, right? So we put in here model. So you can do input type for model 1. You can do it by variable or by model number, right? I'm only going to be running one model, but let me show you what that looks like. So you either put in, and then once I do that, it starts to make this whole thing, right? So conceptual path, this is a moderator, right? So the moderator is moderating X times my exam variable because it knows my exam variable is the dependent variable. It doesn't know what X and W are, but of course, we're not doing a W. We're not doing moderation. We are doing mediation, right? So you can put those in there if you'd like. You would put in revise. So what I'm going to do is I'm going to say, let's just say that the amount of time you study for an exam in hours is going to positively correlate, positively predict your exam score. That's what my independent variable would be, right? So I could put in there to revise my independent variable. It's going to update this to RVS, okay? And then my anxiety is my mediator. So it's going to go ahead and put that in the conceptual. It doesn't change it here though, which is really, really frustrating. So, which is why I don't want to do it in this one. I'm not entirely sure what's not working here. So I'm going to go back to variable so we can specify our path, okay? So the from and the to, the process type and the process variable is really going to help us out here. So we go here. This isn't working for us. So that might be a bug. I'm not entirely sure, but I do know it works if we go through this pathing here. Okay. So from, we want to go from revise. So that's our X variable to exam. Okay. Our process type is going to be a mediator, but we can also do a confounder or direct depending on what your specific research question is. Here, I'm just going to say test anxiety mediates somebody's ability to do well on a test, despite how much time they studied. And the process variable is going to be anxiety. And now you can see I can hit add here. But once I did all of that, it gave me everything that I needed for this particular setup, right? The conceptual path plot is the exact thing that you see up here, right? We're doing a simple mediation, but I can add in here another one if I wanted to. I also want to get my statistical path plot because this will tell me what I'm looking for when I get over to my model, right? So overall model summary is here. So Hayes model number 4, okay, model number 4. AIC is that value, BIC is this value, the log likelihood is that, and the degrees of freedom is 0. I'm not entirely sure what I'm looking at here, so we're going to ignore that and just go into the process itself, right? So parameter estimates. Parameter estimates are causal effects and need to be treated and interpreted as such. Causal effects are only meaningful if all confounding effects are accounted for and their directions are correctly specified. So this is the exact way that I wanted it to be. So let's go ahead and talk about this. So the Hayes model number has to do with the process model itself. So this Hayes model number is 4. So there are different model numbers for however you set up your model. That's what the Hayes model number is, okay? So this is input type. Variables, I think is a little bit easier. Models can be specified by choosing a Hayes model number and adding it to the required. So if I go over here, Hayes model number, that's why I had to change that to 4. Ran into an error. Interesting. There's the stack trace for what happened. So let's go back to variables here. So it's going to rerun the model. And of course, it's Hayes model number 4. So I'm not entirely sure what the issue is here with model number 4, if that's what we're putting in. I'm putting revise in where it needs to go and anxiety where it needs to go. Interesting. I'm not entirely sure why that's not working. Let it run again. Okay. And then you can get options for this. Before we talk about these, you can get residual covariance for your independent variables. It's going to add that down here into the parameter estimates, and it's going to get the residual covariances for mediators. So it's going to add that as well. Okay. Parameter estimates, paths, right? So we have A1, B1, and C1, mediation and total. So it's going to give that here. And then we could also get the residual covariances for that. Although there it is. Took a second too. So these are the residual covariances for that. Now you can get local tests as well. But when I clicked on, oh, there we go. Didn't show up. This model does not imply any conditional independencies. So this would, I think this is only for more complex mediation and moderation. So you would uncheck that. Okay. All right. So we have all of these ready to go. Okay. So I'm gonna go ahead and close up models here and go into options. Okay. Options, we want to get parameter labels. That way we can track what we need over here. It's just an addition to this table here, matches what we've got up here. You can grab the Lavon syntax if you've got the R package Lavon. It will put this at the bottom, I believe, all the way at the bottom, depending on what you've got here for local tests. I think it goes all the way down, but this is the syntax that you need to put this into R. Now, you need the Lavon package to run this, of course. You can get your AIC and BIC weights. I believe that's going to add it. Oh, yes, it added it up to the model summary there. And then you can get standardized estimates. You can get unstandardized, which is what these are right here, these values here. You can get mean-centered. I'm not entirely sure where. I don't think mean-centered actually would have affected anything. And then standardized, so betas, right? Those did change. I'm going to change it to unstandardized. Confidence intervals, you will get confidence intervals for all of your estimates. For your standard errors, I believe, is what these confidence intervals are for. And then You can do standard estimates, robust, or bootstrap it and get a bias, get different kinds of biasing. Let's see how quickly my computer can do this. So you can get bias corrected percentile, percentiles, or normal theory. Ah, there it went. There it went. And it adds the note at the bottom. Confidence intervals are bias corrected, percentile, bootstrapped. And of course, you can specify how many bootstraps. I believe, though, it's 4 characters maximum. So 99999, I think, is the maximum size of this. I think it has to do with the size of this, because then you overflow. Okay, so those are our options, right? So we can collapse that. We can get some plots here. Let's see what we get with covariances. Ooh, there's a progress bar up here. Ooh, nice. So what it looks like is it's going to add the covariances to this plot. Although yesterday, when I was playing around with it, it did not get added because I wanted my parameter estimates to be on this plot, because that'd be a perfect plot to then just put into a paper, right? But nothing was showing up. So let's see what happens with the covariances. Let's see if it adds the values. Yeah, see, it didn't add the values to the path plot, which is an absolute bummer. So we can uncheck that. See, yeah, if I click on parameter estimates, so that's what I clicked on yesterday. And of course, we get the working thing. So this must be something that, not necessarily a bug, maybe not completed as part of the process. But the fun thing is you can see this progress bar up here. That's great. That's absolutely great. What I will try once this is done is to maybe make this a little bit bigger to see if there's some sizing issues, and maybe they'll show up if the graph is bigger. Yeah, see, this has got to be some kind of incompletion or bug or something like that, because with parameter estimates, we lose the label. We lose our path label. So yeah, it's just completely gone now. Yeah, nothing happens. So these path plots, and then so what's going to happen is it's going to do that work again, and it's going to put A1, C1, B1 on there. You can obviously take this. You can like click on it. Let me just click on this. Let me just click on this. You can save the image. I wonder what edit images can do here. This isn't actually all that helpful. Parse titles are expression, text manual. Yeah, you wouldn't actually want to edit these. You would just want to save them as images and then just add the paths to the arrows in like PowerPoint or Excel or something like that. Lots of different color palettes, actually more than recent. So this is the colorblind one. There are 2 other colorblind ones. They all take their sweet time. Yeah, they do. I'm not going to go through them all if they're going to take this long to change the color palettes. My goodness. Is it like work? Okay, it's at least you got the progress bar up here. All right, yeah. So it's a little bit more washed out. I think it's a little bit more pastel-y. Colorblind 3, Viridis. I have several videos on all of these color palettes. Not all of them work. Sports Team NBA and then Grand Budapest. Interesting. Okay. All right. I see you, JASP. Labels and color will be added to these 2 plots right here. Again, we got to wait for the progress bar to load, and then you can label length. You can change that to whatever size. I recommend editing these in another kind of editing software. That's all I'm saying. And then we have advanced options here. There are a lot of advanced options that I am just going to show you, and we'll move on. We'll move on from there to talk about the output here. Okay, so there we go. You can see that 3 letters in the plots. Right, label length are the 3, so that's why these are 3 letters, which works. And then you have a way to distinguish all of the colors for that. So that's how they look. So you can add in residual covariance for your independent variables and your mediators, parameter estimates, path, mediation, total, path plots. Let me check statistical to see what happens for this. We got to wait for it, of course, to go through. So we'll look at what happens there. Tests, local tests, and bootstraps. Okay, again, you kind of need the right path to do that. Okay, adjustment method, you can do Bonferroni, Nunn, Holm, Hochberg, Hommel, Benjamin, Hochberg, and Benjamini, Hochberg, and Benjamini, Ucatelli. Okay, you can handle missing values by listwise or require it to do full information maximum likelihood. You can emulate M+ or EQS, and here you go. You can change your estimator. Now, auto is maximum likelihood. You can make sure it's maximum likelihood by checking that box. You can do general least squares, weighted least squares, unweighted least squares, and I forgot what the D stand weighted least squares. So that's that. Okay, so this is done, and it didn't do anything. Okay, so plots, the path plots need some work. And then finally, you can probe conditional continuous effects and choose your percentiles and add more rows to the percentiles. Okay, all right. Last bit of this video is to talk about the path plots and the estimates, right? And to make a conclusion, to draw a conclusion about our mediation effect, okay? So just to describe here what we're looking at, we're gonna look at I mean, these are obviously the same. This one just has labels here. And we're gonna look at our path coefficients and whether or not those paths are significant, and then we'll talk about what the mediation is. Okay, so C1, this is our direct effect. This is the idea that the longer you, or our hypothesis that the longer you spend studying for your statistics exam, the better you'll do on that statistic exam. All right, so that's the first row here, right? Revise to exam. The estimate is a positive, that's good, 0.24. So for every quarter hour you spend revising your exam, or excuse me, for every hour you spend revising your exam, you increase by 0.24% on the exam, which is a lot, to be honest with you, or isn't a lot, I should say. A lot of time spent studying for not a lot of background. That score generated as a z-score is not significant if we use 0.05, and this is of course our bias corrected bootstrap. So we did a ton of replications. I could uncheck that to see what it would look like if we did more, but it's fine. It doesn't matter. So our p-value is 0.174, not significant. So our direct path, the amount of time you spend studying for an exam, doesn't really help you on that exam. Oh well. So now we need to look at, okay, revising to anxiety and then anxiety or stats anxiety to the exam. We need to look at A1 and B1. So we're gonna look at B1 first, which is the mediation effect, anxiety to exam, right? So how much does test anxiety impact your exam? We can expect a negative relationship with this. The more anxious you are, the worse you're gonna do on the exam. And that's exactly what we see here. So for every point of anxiety increase, the percentage of your test goes down about a 0.5 percentage point, which is pretty rough. And this is statistically significant at 0.01. Okay, so yes, your anxiety is going to be detrimental to your exam score. Now let's look how much revising impacts one's anxiety. Does it lower it? Should it lower it? I mean, conceptually speaking, the more time you spend revising or studying for an exam should reduce your anxiety for said exam because you're doing the learning, you're doing the studying, you're doing the preparation that you need. Of course, there are other factors involved. So we would expect that yes, for every additional hour, we will reduce our anxiety, okay? So that is path A1, and that's what we're down here, right? So revise to anxiety, and it is statistically significant. So for every hour spent, right? This is our strongest effect, by the way. For every hour spent studying reduces anxiety, a point of anxiety, however that's measured, two-thirds of a percentage point on your anxiety, right? Two-thirds of an anxiety point, right? Which is important, right? Because if you have a lower anxiety, then you'll do better on the exam or less worse on the exam, okay? So that gives us our path, but what about the mediation? Do we have an indirect effect or a significant direct effect? Well, then you come down here to mediation effect. So revise exam is path C1, right? So we already have that, and we already know that there is no direct effect between studying and score on the test. And that's because anxiety plays a role here, right? That is a state or a trait that we have that is going to impact our behaviors from point A to point B or point A to point B, right? We have to have some spot in the middle. And so if we multiply A1 by B1 to follow the effect through anxiety, what is our estimate? That is to say, for every hour that we've spent studying for the exam, what's going to be our impact to our exam score? Well, it's still a positive relationship. And the reason why it's a positive relationship is because the more we study, the less anxiety we have. The less anxiety we have, the less bad we will do on our test, which means we will do better the more we study despite our test anxiety. And that is statistically significant, 0.12. There we go. Perfect. So that's our mediation effect. And then we can look at the total effects. So the total indirect effect is the one we just talked about, what A1 times B1. The total effect is C1 plus A1 times B1. And that is, of course, significant. That is to say that in this entire model, there is a significant effect of studying and your exam score when you incorporate test anxiety, right? And then you can come over here and look at our residual covariances to see whether or not you violated any of those assumptions that I talked about at the beginning, right? And then here, of course, is the Levant. So that's why I wanted to use this one, because at least we would get a chance to look at this. Just to quickly show you categorical predictors and grabbing another model here. I'm going to grab model 2. We are going to get a bit of an issue here. Let's try this. Let's go from revise to exam to moderator to gender, and let's see what it will give me here. So this is seeing whether or not there's an interaction of revising to examination if we count for gender, right? Do men do better when they study more? Do women do better when they study more? Does studying not matter with gender? Let's see what, it worked on something and then it decided to reset itself. Let's see if we get into a processing loop here. Oh, there we go. Here we go. Here's model 2. I guess it puts it all together. So okay. So model 2 is actually Hayes model number 1. Okay, great. Okay. So here is what the paths look like, right? So revising the exam. So we're going to be basing this on if somebody is a male, okay? And then over here we have revised gender male. So we have C1, C2, and C3, okay? So do these impact exam? Let's take a look at our path coefficient. So C1 is just the direct effect. We already looked at that one. That's the same as last time. Actually, it did the bias corrected bootstrap, so that's great. No, that's sorry. That's path one or model one. Model two. I'm sorry. Let's go back up here. Model two. Let's open up. Okay. So revise to exam. That's C1 right here, right? That is, yeah, it is statistically significant. And that's because we're collapsing anxiety across the whole, we're ignoring anxiety. So we're collapsing it into the model. And we already know that model is statistically significant. Now, does gender have an impact? Does gender interact with exam? Let's see. The answer is no. Gender does not interact with exam. Now, revise by gender. This is the interaction, right? So there's no effect on just gender and exam. Men and women in this class did equally as good or equally as bad as each other. But if we do the interaction between gender and revising, let's see. C3, do we have an effect? And the answer is no. Well, that's good. I mean, so to speak, right? That's good. That's good. 0 and 1. So gender male, 0 I think is female, and then 1 is male, and that's how it was. That's how the process model is coding it. Okay. And so we can go through the mediation. Well, that would be moderation effects, right? That's what that should be. Revise to exam for just women, statistically significant. That makes sense. Revise exam to just males is also statistically significant. You can tell that those two are about the same exact thing, right? And then here are the total effects, which are essentially the same as the mediation effects. And if you want your Levon, you can do that. So that's mediation and moderation. Two models. Okay. Okay. So that is the classical process model, classical for the use of classical statistics, frequentist statistics, and not Bayesian. So that is how you do the process model, at least basic mediation, basic moderation, how to look at the output, where to put things in this module. It's a robust module, and I can't wait to see how JASP devs, how far JASP devs take it. Is an SPSS killer? We'll see. A lot of people stick with SPSS because they love that process module. Maybe they don't need to anymore. That's going to do it for this video. Please leave your comments, suggestions, other feedback, and questions down in the comment section below. I will see you in the next video. Thanks for watching. Bye.